today in class we started talking about motion in 2 dimensions, which is much more complicated than motion in 1 dimension. And that means that we had to talk about breaking vectors down into components of specific 1-dimensional things in order to talk about them in 2 dimensions. Because if you have some, let's use length for right now. If you have some length here that doesn't fall on x or fall on y, it's got some other direction, and you don't want to rename it on there because you might be wanting to compare it to something over here, then you would need to actually be able to express it in terms of x and y, so that you can then do that for everything and make it standard. So if we did that, if we call this vector r, okay, the line over it for being a vector, then it has this x part to it, and it has this y part to it, right here, and that's the same thing as over here. So we have a triangle that's made up of something on x, something on y, and a hypotenuse on the r. So the value of r is equal to the square root of x squared plus y squared, just from the Pythagorean theorem. And then, if we wanted to figure out exactly how far r was from the x-axis, because that's what we want to do, we want to be able to measure our direction for this too, then we use the other relationship that the tangent of this angle right here is equal to ry over rx. So the value that we have for the y divided by the value for the x. And we can write x and y in terms of our full hypotenuse here and its direction by using trig, so that we can say that the cosine of theta is equal to the adjacent side over the hypotenuse, so that would be the x length over the r length. And if you rearrange that, then you know that the x length is equal to the r length times cosine theta. So if this length were 5 meters, and if that angle was 15, then the x length right there would just be 5 meters times cosine of 15 degrees. The y, you would do the same sort of idea, but it's the sine instead of the cosine, because it's this leg of the triangle over here. So the y would be equal to the r times the sine of theta. And this equation, this equation, this equation, and this equation are all going to be essential for figuring out how to add different vectors together to find either resulting displacements, resulting velocities, resulting accelerations, resulting forces. All of that is best analyzed by doing this. And by doing this, I mean taking some kind of vector, whatever you're looking at, breaking it down into pieces that fall on the x and pieces that fall on the y to make a simple right triangle out of what you have, and then you add everything in the x, that's one separate thing, you add everything in the y, that's one separate thing, and you use Pythagorean theorem to actually combine them together. Okay? So, like if, for example, you were trying to add this vector and this vector, you want to actually get this as your answer right here. And you can do that graphically by doing what I just did. You put the tail of the second one on the tip of the first one and then connect the two, and that's the resultant line. But if you want to do it mathematically, then what you have to do is you have to look at the x of this one and the x of this one and add them together. And you look at the y of this one and the y of this one and add them together to make your new right triangle to figure out what's going on. So, if you do that, this has an x value of this one, which we'll call this theta 1, we'll call this a, we'll call this one b, okay? And this is going to be theta 2 right here. The theta, unless otherwise stated, will always be measured from the x-axis. So that angle is measured from a line parallel to the x-axis right there. Okay? So this is going to be AX, this is going to be AY, and then we have this from here to here is going to be our BX, and this from here to here is going to be our BY. Okay? So then we would be able to, once that happens, we have AX plus BY, AX plus BX will give us some length. Our AY plus our BY will give us some length. So then, if we combine them together, then we get this value for the AX. We get, which will not be to scale, based on my drawing, that value for the Y vector, pardon me, I think I said X before. And then this value for the X part, so this was AX plus BX. This is AY plus BY. And the resulting displacement, the resulting vector you get is going to be that. So you get this new X part after you break these down into the parts on the X, and you get the new Y part after you break it down into the parts that are on the Y. And then you use the Pythagorean theorem to take this squared plus this squared, take the square root, and that gives you the length. And then if you take the inverse tangent of this one over that one, then you end up with the angle. And that's what you're going to want. So if you have to deal with adding two vectors like this, the simplest way is to make a right triangle. And the way to make a right triangle is to break it into x's and break it into y's, add the x's together, and add the y's together. You cannot add an x and a y by themselves. You just can't do it. They're in different things. It's that cliche about adding apples and oranges, or something like that. You just can't do it. Just like in algebra, you can't add 36t plus 15v and have it be anything different than what you said, because you can't simplify that. So you take the x's together, that's one thing. You take the y's together, that's something else. And then you take r, let's give that the name as the length just like before, it'll be the square root of the new x quantity squared plus the new y quantity squared. And that's what you would do, and you would take the inverse tangent of the new y over the new x to figure that out. Like I said, this will be very, very important for dealing with displacement and velocity, acceleration, forces, everything we're going to be dealing with for the rest of the semester, and also for the next semester too, for those that are taking that course. So it's very important to understand what's going on with this, and we will be doing tons of examples in the next class in order to make sure that understanding comes across.